Assalamu alaikum. Here's Muhammad Saad, and today we'll have a detailed discussion about a device known as Raspberry Pi. Oh, so what's Raspberry Pi? What's with the funny name? A raspberry, a pie? It sounds quite yummy, sort of a French or English dish. Oh, sorry, I'm getting away. Googled it and came to know that it was a silicon chip, probably used as a circuitry component or as a relay device. Oh, again, I'm getting away, and I must tell you that it's a computer, a full fledged computer. Well, that's a Raspberry Pi, that's a Raspberry Pi, that's a. Sorry, my bad, that's just a Raspberry. So, what is it? Raspberry Pi is a single chip computer as you have seen earlier. It comes with an integrated full-fledged devices, processor, RAM, AV support, the entire peripheral support. You can connect the keyboard, the mouse, the camera and everything what you require. Plus it comes with Wi-Fi and Bluetooth. So the wireless connectivity that has always been an achievement for the remote devices is also achieved in this device as well. Let's have a look at its structure. Right here I've got a 3D model of a Raspberry Pi. You see it is controlled by the mouse. It's not a full form of the picture, still it shows the entire needed component to explain the Raspberry Pi. Here I've got an Ethernet port. It comes with the 4 USB 2.0 ports plus a 3.5 audio jack and HDMI port, so you may see what it is processing or what it is offering you. Here comes a micro USB port to support the charger and the other OTG devices. On the underneath it has an SD card support which acts as a hard drive for this device. You will have to boot up the SD card and it will contain all the information necessary to boot it up and the other devices to work with. Here is a camera support port. The old cameras and the new cameras that offer a port to connect with the computer to gain live information or the processed information, and here is a display port. The classical display port used to integrate with the graphical card. On the inside, which is not present over here, it contains the embedded processors and the connectivities. Let's move back to the slides. Raspberry Pi, here's a complete look at it. You see each and every part mentioned with the names. Let's move ahead. So why Raspberry Pi? I mean, we have got smartphones, we have got the original PCs. What is the need of this device? Originally it was designed for educational purposes. So let me get you a calculation. A CPU, a full-fledged CPU working in the modern day will cost you round about approximately $100. Probably if you want a good one that will go for a $300. But this Raspberry Pi, which contains a processor, a RAM, the all AV components, just costs you merely $30. Plus it was originally used for the educational purposes. Like, it may be quite costly if you have to train around about 30 students with an individual PC, so it will be better that you buy peripherals like mouse, keyboard, speaker and the devices, plus you provide them with a small Raspberry Pi, easy to boot, easy to use, easy on pocket. Plus another thing it contains is that it has a good integration with the robotics, the customized circuitry when you're working with the other customized devices. Like previously I was visiting a project and it contained a software which used to control the engine parts, like it may be open the car, when lock the car, it may even break down the engine circuitry. So a Raspberry Pi was there controlling all the relay flow. It will be an exact statement that it is an excellent bridge between the modified hardware and the modern programming languages, which is not by far a big achievement that has been achieved right now. So let's move ahead. Okay, I've got a Pi. What do I do with it? It doesn't come with an OS pre-installed on it. You have to do something to install an OS. So once the OS is installed, it has got the OS. It boots up like a normal computer, and you can do everything what you can do with a normal computer. How to set up the Pi? Let's have a look at it. I'll move back to the browser for this purpose. It goes, and on the Raspberry Pi's official website you have got this downloads column. In the downloads column you will see some of the OS options provided by the Raspberry Pi company by themselves. Here I've got the Raspbian and Noobs. Raspbian is the original OS and Noobs and is its installer. Plus, this is the official OS provided by the Raspberry Pi. We have got other OS provided by the third parties like Ubuntu, here goes the Windows, and the other parties as well, which may be useful. But the preferred by the Raspberry Pi institution is Raspbian because it is they believe that their engineers are working on it quite hard. It is the most efficient OS available for this device currently. So once you download this software, you have to need something that can burn this OS onto an SD card that actually acts as a hard drive for this Raspberry Pi. So the most common disk manager or the burner you will use in Windows is Windows 32 Disk Manager. It just acts like another burner which you use to burn other OS like Windows or Ubuntu to burn on a USB so that it can be bootable. Once it has been done, you can simply connect the peripherals like we mentioned, the HDMI, the USB ports, the peripheral devices like mouse, keyboard, and you're ready to move on. Officially, the OS preferred by the Raspberry Pi company is Raspbian, as discussed earlier. It is originally based upon Linux, as like several other OS. And luckily, Raspbian supports all the shell commands which you want on a Linux device. The big question: I've got a Raspberry Pi, I've got an OS installed. What do I do with it? I mean, how do I code? Do I need to set up another package of programming languages? There's separate integrated development environments or something like that. For that luck, Raspbian comes with a built-in Python support, along with an IDE as well. It supports quite a handsome amount of languages, like it supports Scratch, it supports Mathematica. Let me see if we've got full-fledged information on which languages does the Raspberry Pi supports. Well, here we go to look. The official documentation of the Raspberry Pi says that it's better to write and read the programs in Python. Plus, the other languages supported by Raspberry Pi include Mathematica, Python 2, Scratch, Sonic Pi, Wolfram, etc. etc. Scratch is another language which is preferred for children to use because it is easy to understand and easy to code in. Moving back to the slides. Sorry, my bad. Okay. The Python can be used with a built-in IDE known as IDLE3 or IDLE3, what you may call. It's simple. When you have opened IDLE3, if I ask for your intro, name, username, password of the OS, and start to code, save, execute, whatever you do in a general IDE. Good. So, if I want to use it in robotics, what am I supposed to do? Like, I am not having a monitor on an LED support where I can see what my Raspberry Pi is performing. So it's some sort of what we call a headless mode of Raspberry Pi. Like, you are not connected to a monitor or an LED. You want to access, you want to see, or you want to connect it with the robotic component so that it may receive the input from its sensors and it may return the output in a useful manner and can be used by other robotic devices. So the key factor which needs to be handled over here is that we may write an application for an input to an output mapping, but how to achieve that thing? So it is known as the headless mode. Actually, the thing you need to justify over here is that your application needs to start on its very booting. Like when a Raspberry Pi boots, it needs to execute your application. So there are quite some ways to do that. Here I have got a list of these things. This says that you have got 5 methods. Well, you can read them out. The easiest of them is editing the rc.local file. The basic thing that it does something with the booting files. Like rc.local is a file associated. It contains some scripts that the Raspberry Pi executes at the time of booting. So what you do to write a code, you take its script, you take its Python file, its absolute address, and place it at the end of the scripts that this file already contains. There's an ampersand so that it doesn't produce any daemons or continuous child processes in an infinite loop. and end with an exit of 0. And the next thing, when you boot up the device again, the first thing it will perform is that it will execute this application. So whatever your application you may have written, you just take it out, its absolute address, move it in this rc.local file, and this application would work by the time of your startup. There are a whole lot of ways, including a whole lot of tricks and a whole lot of details. Depending upon the seriousness of their application, it's working, any of these methods employed can be used. A good thing about Raspberry Pi is that it provides a good integration with other technologies like Arduino, Google. Google is supporting a whole lot of technologies with Raspberry Pi. It's providing an excellent kit, an excellent suite that you can use with the Raspberry Pi. So, if you know how to do with it, how to deal with it, you have surely got a good scope in the future in the robotics, in the mechatronics, and the devices. Well, Raspberry Pi can be a dodgy name. I mean, it sounds like a dish, a fruity dish. Can we actually trust it? Well, if we can trust a company from US with the OS named as Lollipop, KitKat, Marshmallow, so surely Raspberry Pi also deserves a go. That's all from me. Thank you.